Introduction to Techniques and Methods. Rigging isn't about ropes. It's about control. Because the moment a piece of wood starts moving, everything changes. You're no longer just making a cut. You are managing force, weight, energy, and momentum, all at the same time. And whether you realize it or not, every decision you make in that moment affects what happens next. If you don't understand those forces, you're not rigging. You're reacting. And reacting in tree work is where things go wrong. In this podcast, we're going to build your foundation from the ground up. By the end, you will understand the core concepts and terminology of rigging. You'll be able to recognize and distinguish between different rigging techniques and methods. And most importantly, you'll begin to understand how to apply those methods to improve both safety and efficiency when lowering limbs. Let's start with the most important definition. Rigging is the controlled movement of wood using rope systems. That word control is everything, because gravity already knows what it wants to do. It wants to pull everything straight down. Your job is not to fight gravity. Your job is to guide it. Every time you rig a piece of wood, you are managing 4 fundamental elements: weight, force, energy, and friction. Weight is the mass of the piece you are cutting. It's what gravity is acting on. A small limb might weigh 50 pounds. A large section of trunk might weigh several hundred, or more. But weight alone doesn't tell the whole story. Force is what that weight applies to your system. And force increases as movement increases. For example, if you slowly lower a 100-pound limb, the force on your system might stay close to 100 pounds. But if that same limb drops even a short distance before the rope catches it, the force can multiply several times over. That's where problems begin. Energy is what builds as the piece starts moving. Think of energy like stored potential. When a piece is sitting still in the tree, it has potential energy. The moment you cut it, that energy begins converting into motion. That motion is what your rigging system has to absorb. And finally, friction. Friction is what allows you to control that energy. Without friction, the rope would run freely, and the piece would fall uncontrolled. With friction, you can slow, stop, and guide the movement. Friction is what turns chaos into control. Now let's go deeper into movement. Because movement is where most rigging mistakes happen. The moment a piece is cut free, it begins to accelerate. Acceleration is how quickly something gains speed. Even a small piece can accelerate very quickly under gravity. And the faster it accelerates, the more energy it builds. As that piece moves, it gains momentum. Momentum is mass multiplied by velocity. In simple terms, it's how much push the moving piece has. This is why a light piece moving fast can feel heavier than a heavy piece moving slowly. Then there's displacement. Displacement is how far the piece travels. A piece that drops 1 foot behaves very differently from a piece that drops 5 feet. The farther it moves, the more energy it builds, and the harder your system has to work to stop it. Now let's talk about direction. Because pieces don't just move. They move along a path. That path is called a vector. A vector has both direction and magnitude. Magnitude is how strong the force is. Direction is where that force is going. Here's a real example. You're removing a limb that extends out over a roof. If you tie it near the tip, that piece will likely swing downward and inward toward the trunk. If you tie it near the butt, it may drop more vertically before swinging. The direction of that movement is the vector. And if you don't predict that path correctly, the piece can swing into the structure you're trying to protect. Now let's break down every rigging system. No matter how simple or advanced, every rigging setup has 3 core components. The first is your anchor point. This is where your system is attached to the tree. It might be a natural crotch, where the rope runs through a branch union. Or it might be a false crotch, where you install a pulley or friction saver to reduce wear and improve efficiency. You may also use a floating anchor, which allows the system to move and distribute forces more evenly. Or redirect rigging, which changes the direction of the rope to control where the load travels. The anchor point is critical because it is where all the force is concentrated. If you choose a weak anchor, the system can fail, even if everything else is done correctly. The second component is your rigging line. This is your load line, the rope that carries the weight of the piece. But it's not the only line you might use. You may also use a tagline to control the direction of the piece from the ground. A pull line can help guide or tension a piece before the cut. A speed line allows you to move material horizontally across a span. And a load transfer line can distribute weight between multiple points. Each of these lines plays a specific role. And understanding their purpose allows you to build more efficient systems. The third component is your control system. This is where the ground crew manages the load. Friction devices like a porta wrap or bollard allow the rope to be wrapped in a way that creates resistance. That resistance slows the rope and controls the descent of the piece. Think of it like this. The climber sets the system, but the ground crew controls the outcome. Now let's talk about how we attach the rope to the wood. Because connection is everything. One of the most common knots is the bowline. It creates a fixed loop that won't tighten under load. That makes it reliable and easy to untie after use. The clove hitch is fast and adjustable. It's useful for temporary attachments, but it can slip if not backed up. The cow hitch and girth hitch are simple wraps that hold well under tension. They're often used when speed and simplicity are important. The timber hitch is ideal for logs. It tightens under load and releases easily once the load is removed. Half hitches and marline hitches are often used to stabilize a piece. They help control rotation and keep the load aligned during lowering. You may also use slings instead of tying directly into the rope. Slings like dead-eye slings, whoopee slings, loopy slings, and webbing slings allow you to attach quickly and adjust as needed. Now here's a critical concept. Rigging doesn't start with the rope. It starts with the cut. The way you cut the wood determines how it behaves when it separates. An undercut is used to prevent tearing. It creates a clean break and helps control the release. A back cut is what actually frees the piece. The timing and placement of that cut determine how the load transfers into the rope. A notch or hinge cut allows you to guide the direction of movement. The hinge acts like a steering mechanism. It controls how the piece falls, how fast it moves, and where it goes. If the hinge is too small, you lose control. If it's too large, the piece may not release properly. There are also specialized cuts. A drop cut allows a piece to release quickly. A lifting cut can introduce upward movement before the piece falls. A topping cut is used when removing the upper portion of a tree. And sometimes, the wood itself introduces complications. A cavity or conch may indicate decay, weakening the structure. This affects how much load the wood can tahammil and how it will behave under stress. Now let's talk about rigging techniques, because this is where everything comes together. One of the most common techniques is the tip tie. You attach the rope near the end of the limb. This allows for more controlled movement and reduces the likelihood of a sudden drop. The butt tie attaches the rope closer to the trunk. This can be faster and more efficient, but it often results in more force being generated because the piece can drop farther before the rope catches it. A balancer uses 2 attachment points. This helps control the orientation of the piece, keeping it level as it moves. This is especially useful when working over obstacles. Balance is critical. If a piece is not balanced properly, it will rotate or swing unpredictably, and that unpredictability increases the risk of shock loading. Another technique is blocking. Blocking involves removing sections of wood, often vertically. It's common in removals, but it generates high forces and requires careful control. You also need to choose between natural crotch rigging and false crotch systems. Natural crotch rigging is simple and uses the tree itself, but it increases friction and can damage the rope. False crotch systems use pulleys or friction savers. They reduce wear and allow for smoother operation. You may also use redirect rigging to change the path of the rope. This can help avoid obstacles or improve control. And finally, you need to understand the difference between running and fixed systems. In a running system, the rope moves through the anchor. In a fixed system, the rope is anchored in place. Each has advantages depending on the situation. Now let's bring everything together. When you cut a piece, gravity applies force. That force causes acceleration. Acceleration builds momentum. Momentum transfers energy into your system, and that energy must be absorbed by your rope, your anchor, and your control device. Here's the key idea. The system doesn't feel weight. It feels movement. And when that movement involves rotation, you introduce moment. Moment is rotational force. It's what causes a limb to swing, twist, or roll. And it's one of the most common reasons pieces behave unexpectedly. Let's walk through a real-world example. You're removing a large limb over a house. You set your anchor point high in the tree. You install a false crotch to reduce friction. You tie the limb using a tip tie for better control. You add a tagline to guide the swing. Before you cut, you think through everything. How much does the piece weigh? Where is the center of balance? What path will it travel? What happens if it swings? You make your undercut, then your back cut. The piece begins to move. The rope catches. The friction device engages. The ground crew controls the descent. And the piece lands safely. That's rigging done right. Now let's look at what happens when it goes wrong. If you underestimate the force, the system can be overloaded. If you choose the wrong technique, the piece may swing unpredictably. If you don't use enough friction, the rope can run too fast. If you use too much friction, you can shock load the system. If you ignore defects in the wood, your anchor point may fail. Every mistake comes back to one thing: a lack of understanding. So here are your key takeaways. Rigging is about controlling movement and force. Every system includes an anchor, a rope, and a control point. Your cuts determine how movement begins. Your technique determines how that movement behaves. And your understanding of physics determines whether the system succeeds or fails. In the next podcast, we're going to break down equipment and ropes. We'll look at how different ropes are constructed, how hardware functions, and how to choose the right tools for the job. Because understanding the system is the first step, but understanding your equipment is what makes you precise. You've been listening to the Arborist-podcast. Our goal is to grow our collective knowledge, one domain at a time. If you enjoyed the podcast, please like, share, and subscribe to help us keep this momentum. Until next time, let's keep growing this community together.